turn the presenter over to Duncan Mallace. All right, Duncan, you got that?
Yeah. Can you see me now?
We are seeing you, yes.
Good. All right. Let me go full screen on this one for a moment. Okay. Welcome everyone. This is the first presentation of really the not quite a completely joined up set of applications, but it's certainly the initial stages, and I'm going to show you how to set up QINSy properly for Fledermaus. This is really down to setting it up for performing some of the backscatter for the FMGT application. I'm going to show you how to record the data correctly for the various bits, how to use QINSy data within the various Fledermaus products, and then also a look into the near future, which is going to be even closer integration in that. This is all, to do any of this, you need the latest Fledermaus release, which is 732A, or 732 is when we did the QPD interface. So anything 732 and beyond, you'll be able to do what I'm doing today. Similarly with QINSy, you'll need best to download the very latest release. There was a patch recently, but the main one is the 21st December release that came out. So that's on the QPS website for both software packages. So the first stage, if you like, is you can actually add Fledermaus to the QINSy console, and you'll see down here at the bottom there, I've added in Fledermaus, DMagic, FMGT, and FM Midwater. Now I'll just show you. Just sometimes you've used it to down here. Now you can add and remove QPS programs or QINSy programs from there. At the moment, to add a Fledermaus program, you need to do the Add Program option, and then this depends on. Then you have to either. I'm on the Windows 64-bit on here, so if I have 32-bit Fledermaus, it comes within the program files x86, and if I have a 64-bit, it's Windows program files, IVS7, the bin folder. And then any of these ones down here, say if I want to add cross-check into it, I click on cross-check and do open. And then we have cross-check down here. So, so if you want to have a nice, easy to get to state of affairs, then this is quite a good way. You can't actually, I was trying to reorganize, but you can't do that just yet in this bottom panel. But yeah, so that's quite nifty. Going back to the presentation, one of the things I'm going to show you now is really which drivers to use for any of the Fledermaus products, really. And this is really geared down to two drivers in particular, or two sonars in particular, which is the ultrasonic sonar and the Rezon's CBAT 7000 or 8000 series sonars. This is when you do a DB setup, you select on the multi-beam echo sounder type, you select what type of multi-beam echo sounder you're using, and you have the drop-down list that selects them all. The one that you have to select for anything to do with backscatter is the XTF option. This is important at the moment because it's XTF that actually contains the snippet information from the Rezon and the ultrasonic systems, but this is going to also be the case when we start reading backscatter out of the DB file, which I'll come on to later on. So you have to choose the XTF option because the XTF option logs all the raw data and also all the settings that go in to the packets, which allow us to correct the backscatter for to take out things like power and gain, and those settings, they only get stored if you log in XDF. So just to let you know, that's imperative. You must select those. If you select any of these ones which are non-XDF, then you'll have errors coming up in FMGT and you won't be able to log the data. It doesn't matter for Bathy. That creates a QPD file and we read that in. That's not the issue here. This is for backscatter generation. So and just to show you on that one, if I go to my setup, then when I log on to and edit my, this case, port 7125, you have the Reson CBAT 7K option here, and it's the XDF option. So it doesn't matter which one providing, it says XDF. Also, when we're using QINSy now to bring in QPDs, this is also in the DB setup where you set up your total propagated uncertainty values. So on this next page here, or two down, you've got the echo sounder accuracy parameters. Every time you load a sensor into QINSy in DB setup, it asks you for your accuracy parameters. So on here, it's actually a 1 degree along system, it's a ½ degree across, it's a flat transducer, and we're using a POS-MV, so we're very accurate on our roll, pitch and heading. So these are the values that will say how accurate the data is when you bring it in. So every time you see a standard deviation, an SD, when you're in DB setup, this is all to do with TPUs. So make as good a judgment as you can, or as your best judgment, when you're pulling this together, and then you finish. So so that's in the setup, or you can do it in replay. If you've already got data that you required, you can come in here, and on the database setup, you can go back in and redo exactly the same thing, which allows you to recompute your QPDs with the correct total propagated uncertainty values in them. One of the things we're going to do now is, well, I'll show you when we actually go online. I can just take you through a couple of steps here which will save you a bit of time. And that's when you go into, this is the same online as it would be. I'm doing it in replay mode, so but basically the functionality is the same. And this is all to do with a session setup, which is what files you're recording and how you go about setting these up. One of the things that you can record in real time here is a sounding grid, which is basically a digital terrain model. This is what you see in real time in QINSy, and this is a really quick way of getting the survey area into Fledermaus, because we can now read this file directly. So if you create a sounding grid, you can make a new one, give it a name, and then the cell size here is whatever cell size you think you want to run at, and that's all you need to do for doing this. You then specify down here on the bottom which one of these systems, in this case we have bathymetry, backscatter and side scan sonar, and we select which one of these we want to use in the data, which is the bathymetry one. And then when you log the data, it will create the grid on the fly as it goes. The DTM file here is not a digital terrain model. This is point data. This is the QPDs, and this is where you set the different format types that you can bring in. And the one to be aware of here, when we're doing QPDs, the normal one to bring in is this top one here. The QPD reduced file is with, if you do any online filter settings, these will flag data as being flagged by those settings, they won't make it into the QPD. So if you try and make some settings, I'll show you the settings in a moment, and you want to then go back and say, okay, well that was taken out by accident, then if you choose the reduced option, you won't be able to change anything. You've already taken that data out. So this is the option that I would always use. And then one other thing to note, this doesn't matter at the moment, but will matter in the future, is it's a really good idea to make sure that your QPD name is the same as the DB name. This is not, say, necessary now, but when we start to do things with the DB database file and the QPD together, we really need to have them the same name. It's not essential. I don't think they're going to be able to work around it, but it makes life a lot easier if you call the QPD the same name as the DB file. And then down here it's making sure that you have the right system if you've got multiple systems in the QPD. And we can have multiple sonars into the QPD as well. So if you have a dual head Reason system or Artisonic system or Kongsberg system, then you can log both heads into the one QPD file, and we read that into the Fledermaus products now. The other setting I was saying about, one of the really excellent things about having a seamless workflow from acquisition through to processing is that you get to all the settings that were done online. You know, the guys on board the boats, they know what how the system's performing, if it's got bubble wash, if it hasn't, how basically to tweak this system to get the best data you possibly can out of it. And with every other software package, you've always got to start from scratch again in the processing flow line. So this is really good because we can make changes here to the data, which then get propagated all the way through to the Fledermaus products and to the final QINSy products. So on this particular data set, I've said that we don't have any depths that are less than 3 meters. We're shallow water. We're not going deeper than 35. The brightness and collinearity, these are specific Reason quality flags that you can also use to flag out data. And I've also just put in a spike filter as well, just to take out some of the big spikes. And you can do refraction correction here with the velocity profile and just enable it. That's not essential. If you want to, you can redo sound velocity and things in Processing Manager, but this will give you a decent looking data set. So with these values, these are all flagged, and these flags we are aware of when we bring the QPD files into the various products. And then you press go and it will replay through and it will create QPD files. I won't actually do that at the moment. Just to give you a guide to where things go, this is the QINSy data folder structure. I've also added a couple more folders in, but I'll show you that later. This is basically sticking a Fledermaus project within a QINSy data project and also an FMGT project as well. Those are there. The QPDs are stored in the DTM data folder, which is in here, and if you have more than one sensor there, it stores the data there. So these are the QPD files that we'll be reading in later. And then once you've done your QPDs, if you want to immediately start on your backscatter work, then we take these QPDs. At the moment, we need to create an XTF file and a GSF file from these QPDs. To create the XTF and the GSF file, you can either hit this button here, which is export, or you can right-click and you can do export. Now, this is for both the XTF and the GSF you can do from here. The XTF I'll do first, and there are some specific things in here you need to make sure that you do. When you do the XTF export, select the file that you want. It's going to be one file name. I shall override it. And then if you've got more than one system, you select what the system is. This is Reson again, so it's exporting the snippets. This is the same with Artisonic, so this is to make sure that it's exporting the right records there. If you have more than one heading sensor or attitude sensor, you put select it there. Same with if you have more than one navigation sensor, you set that there. And then this is the really important part. For FMGT to do proper job on the backscatter processing, you have to set the right series of sonar. So if you've got a Reson system, it's in here. If you have an Artisonic system, it's down here. And the same, I mean, I wouldn't, you have got the Constable 3000 things in here as well. So make sure that you select the right sonar setting. Don't select the QINSy setting, because that's just to, that was just written originally just to get data in. It's like a generic XTF format. We need to know what the sonar type is to enable us to correct for a beam pattern and things like that. So that's particularly important. And the rest of it is just normal standard stuff. You just press finish to create the XTF file. The GSF file, you have to do the QPD part. You have to have QPDs before you can do the GSF part from here, because the whole point of the XTF-GSF combination is the GSF file contains the XYZ information that goes with the snippet, so we know exactly where the snippet backscatter is. So this has got raw and results data GSF, so we need that information. You need the QPD first before we create this, otherwise it won't let you do it. And then you create a little template, so we can add a template here. This one, if you just do it, it's the same as the basically the same as the XTF. You're doing 7125 here. At the moment with QINSy, it supports writing the backscatter data from the 8000 series Resons only, not the Artisonic and not the 7000 series Reson systems. So select the system that you have in the DB file, again with a heading and the attitude and the nav, and then it's just going to create the same name as a DB file, which is what you want, because that's the same as the XTF. And then when you export this one, one of the things to note is that I've got this in saying beam count is forced to 512 beams. Let me go back to the presentation to show you this bit. This is specifically at the moment for the Reson 7000 series, and I'm just going to flick through to the GSF export here. There is a registry, there's an update. I'm not quite sure, and Hans will be able to say exactly when this was officially released. But the problem is if you have a 7027 data packet, the 7125 doesn't store 512 beams every time it pings. If it doesn't get a return from a particular beam, which is the 0 quality flag, it doesn't actually record the beam within the data packet. So some of your beams might be 510, some 493, and when FMGT starts to match the ping and the beam in the XTF with the ping and the beam in the GSF for the Bathy, it all gets very confused, and the program doesn't work. So there was a fix in here in the registry to force the beam count, and you basically specify how many beams you have in that 7125, and then in your GSF output it says beam count is forced to 512 or 256 or whatever you're running at there. And that's only with the 7027 data packet. If you're recording that, which is the main data packet now for the 7125, you need to. So this is it should be a short-term fix. There'll be once we have a better understanding of what the sonar is doing, it would be easier to make a better way of doing it than hacking the registry. It's not really a hack; it's putting an actual value in there, but it's a way around doing it. So so that's basically got the data now in a format that you can bring into Fledermaus. So we've created a sounding grid, which is a digital terrain model. We've created QPD files, which is basically just bathy data. We've created XCF files, which contain the snippet backscatter data, and we've created GSF files to go with the backscatter with the XTF files. So the first one, which is a really good and very quick way of having a look at the data, is to bring the sounding grid that's created directly into Fledermaus. And you do this in Fledermaus. You don't have to use dmagic for this, and you can use dmagic for this, but if you want a quick look, it's easy just to bring it into Fledermaus. So you do import in Fledermaus and import gridded data. I'll show you this in a moment. And this is really just to show you where the sounding grid resides. This is in the in that QINSy project. Sounding grid lives in the grid data folder. So this is our .grd file here. And this is it for a quick look into in Fledermaus. In dmagic, everything is set within the Fledermaus project structure. Within Fledermaus itself, if you just bring in a file in, it saves it in the same place as as whatever file it was that you brought in. So here I just did a couple earlier, and they're saved in the same folder as the grid data. So just to let you know where they go. But to give you an idea how simple it is, I'm going to just make it so that I won't do full screen on this one, a bit bigger. So let's do import at the top here, import gridded data, and then go to my Dover project, select my grid data folder, and select my grid that I want to bring in, and I press open, and it automatically realizes that this is a QINSy grid, so it says QPS grid. If you've done a QPS grid, so you can, if you've had things like sounding density or standard deviation or something like that, you can select that layer from here, and then here you've got the option of the medium, deep, shallow data. So this is all set in the sounding grid itself when you make it, and then we do next. It doesn't know what coordinate system it's in, so you have to tell it. So I'm in zone 30 north, and then quick as a flash, it reads the header, it tells you what the extents of the data are, Z bounds, Z min, max, and easting and northern bounds, and then we do next. You don't have to worry about inverting data because it knows it's all in the reader for the sounding grid. We know which way is up and down on it, and then we specify what coordinate system we actually want this data to be in. I'm going to leave it in zone 30, and then we do next. By default, it gives the same name as the file of the sounding grid that was bringing in, which is great. You have two types of data you can bring in here. This is a digital terrain model. This is the Z part, so this is why I'm choosing Sonar DTM. If I had sounding density or standard deviation, then that would be a scalar. It would be X, Y, and whatever value that was. So that's there. And then choose your favorite color map, and default parameters, your own favorite ones, and do finish. And there, this has got some spikes in it still, quite a few spikes in it still, but it's a really quick way of looking at your data and seeing what it's like generally. And you can go into, and in this I just replayed, so I could go a little bit more to town on this to take out a bit more of the data. So that's the sounding grid. Going into Fledermaus, you can export quickly to Google Earth if you want to, to really impress your clients at how quickly you can get data out there. You can export to Google Earth, export surfaces and images, saving it as a GeoTIFF, and the create survey area object I'll show you on in a little bit, and the export to bag. This is a bathymetric attributed grid. You wouldn't really normally do it here. This is only if you had historical data, not in a PFM. So that's the sounding grid. Very quick, very simple, and immediately shows you what you've got. And if you've got nice clean data and all the rest of it, you can build your scene up straight away. You've got RTK. I mean, you could have almost the whole data set done just by bringing it in. Very unlikely, but you never know. The next part is this is bringing the sounding grid in. I'll just show you. The next part is actually bringing the QPDs into DMagic now. If you want to, if you have only like a few lines, then most of the functionality, apart from data cleaning, just gridding data and things you can do in Fledermaus. If you have quite a few lines or multiple day surveys, then DMagic is where you want to be, because that's where the whole, you can do a nice directory structure and see where the data is going. So this is just to show you it's the QPDs in here. Something new also in 732 within DMagic and Fledermaus is that there's now a project history that gets recorded as you go. So this says when you're adding source files, converting images there, interpolating a grid, which I did, building a PFM, and again when you click on the PFM, it'll tell you what the attributes were when you built it. So that's quite useful. I'll do this in DMagic as well, but just to show you again, this is QPDs are ungridded data. They're not gridded data. Gridded data is regularly spaced points. This is point cloud data, basically ungridded data. And when QPDs are stored in QINSy, they're stored in the DTM data folder, which is a little bit name-wise a bit confusing sometimes, but it's in there. It's either straight underneath that folder, or if you've already taken it into Processing Manager, you'll have a subdirectory in there as well with the name and the sensor. So that's where you go to bring it in. And then just to show you, this is basically what we see within the QPD file. And then when we're bringing data in for creating cube PFMs and for processing cube data, we have the horizontal and vertical error associated with it here. And then this is just a list of the files. So to show you how that's done, this is one I created earlier, but I'll create, do I want to save? Yes, might as well. So I fire at DMagic. Now the nice thing with the QPD reader is that this is not reading through any DLLs or libraries, so this is multi-platform compliant, the QPD. So if you're running Linux or if you're running Mac, then you can bring in the QPDs as well. So with DMagic, the first thing we do is create a project. So this one is find your location. I'm going to store this under my Dover folder, and FM Dover I'll call this one. And this coordinate system is where you want your data to be. So zone 31 north is where we want our data to be. To bring the QPDs in, we just go to add ungridded data. Just right click on there, and we can do file, add source data. The easiest way to do this is to add a directory, but the first thing you want to do is just untick this include subdirectories, and I'll show you why in a moment. And if you do add directory, and in DTM data is the one you want to or this one, I've got a subfolder of it, then it loads it up. Sometimes within some of the QINSy data folders, you'll find that there is a subdirectories that don't normally contain anything like Donna and things which are in the export folder. So it's always a good thing just to untick unless you've got data in subdirectories, then you would do that. But this just brings in one folder. So there's our QPDs. Now it's asking us what coordinate system these are in. Now at the moment we have to specify what coordinate system it's in. It doesn't bring it through from the QINSy geodetic. The longer term goal is to have a common geodetic library between the two main all the applications, and then you won't have to do this, but at the moment you have to specify where in the world, what coordinate system these QPDs are in, and these are in zone 31 UTM zone here. This bit's already filled for you. And then when it opens it up, then it's just scanning the data through and creating the project as we go. And then we can bring up the one I created earlier once they're in. No, don't want that one. I'll have that one. Oh, wrong file. Just running the wrong program there. Sorry about that. Nope. And try the F and project. I think I moved all this data around, so I'll go back to my previous one. So that's reread the metadata in there. I also added in a background chart for this. So if you want to, now you've got the QPDs in here, you can do everything that you could with, say, FAU files or GSF files or whatever you used before. We can come along and select a box over our area. That highlights the files that we want. And then we can right-click on here, and you have the option to grid it, which is going to create a regularly spaced grid. And this is, if you've already done a sounding grid with the data, then there's no real need to do this at the moment. But just to take you through the steps, you select the files will select automatically. The value to grid, the Z value is what we want to grid. It knows what coordinate system we're in. We're expecting to be in the project coordinate system, which is correct. And then it's telling you what cell size to choose, and the bounds of the area are already there. So that tells you how many rows and columns you are, just in case you run out of memory. And you specify the color map that you want and the surface. So this is exactly the same as, those options are the same as bringing in the gridded data before. So this gives us a file, and we'll save it down, and then let's click out here. That's now our gridded data set that we had. We can also, if we want to process this data, select the area again, and we want to build a PFM. We can use cube because we set up those TPU parameters in the DB setup. Again, it knows where the coordinates, the QPD file, what coordinate system they're in. This is the project system. This is the bounds of the PFM. Remember, with the PFM, if you are adding data, appending data to this PFM later, like day 2, day 3, etc., this bounding box here has to be the total bounds of the survey area that you're going to use. This is the bin size that we use. This is a 1 meter bin because it's nice and shallow, and we tend to do it's quite an easy way of doing it. 0.71 times whatever your cell size is. So it's 0.71 today. And this is setting how far away from the cube center you're going to use data. This is the cube resolution, hypothesis resolution. Number of samples normally works best. This is where cube decides which solution is correct. And we normally drop the estimate offset down to 2 to create more hypotheses or more multiple choices for the depth. And also we let the horizontal error scale run a bit slower. That's just personal preference. But now when you come to do the TPUs, is now saying where we're doing cube processing. Where do I find my errors, my computed total propagated uncertainty? So here we have horizontal error is mapped accordingly, and vertical error again, and those are mapped in here. So those fields are used automatically. There is no point doing enable custom filters because in DB setup you've already done all the filtering, or not in DB setup, sorry, in the online system you've done all the filtering, and then just give it a name, and it will create the PFM. In my project here, PFMs go in the output folder, and there's a PFM folder, and that's where the PFM lives. We can then double click on it to fire it up in Fledermaus, or I'll just wrong one. Sorry about that. That's good. Various things running. So if I go to recent projects, then the Dover Cube one will be in there. This is my big red splodge to the amount of the, this is the area of the PFM, and this is where the data is at the moment. So if you remember, the previous data was quite spiky when I did the sounding grid, which was this one. Oh, okay. Oh, because I changed it. I did the wrong coordinate system. That's not very good. Showing more functionality of Fledermaus here by reprojecting my wrongly coordinate system data into this one, which might actually not work. Actually, that won't work. Let me just crash Fledermaus, which is the easiest way to do it. So if I do that one again, so this is my very noisy sounding grid data. Clear my scene and bring in to PFM now. Now I'm extracting the whole area. I could extract a little bit less. So this is the same. There's obviously some data here right on the outer edges where you've still got spikes, but a lot better than it was before. And then to process today, just to show you this nice rec, you've got all the color by uncertainty here. It's like standard deviation, and then you just change your color map to show a bit more information. So then you can see where your X are and the overlap between the lines. And what we normally do is color by the number of hypotheses. This shows you where where there's multiple choices for the same area. Put that down to 3, and so it's easy to see then where the issues are. This is our rec, and we can zoom in here. Just drag the exaggeration down. Now, before we, I've got my little bar here in the way at the moment, so I'm just going to move this a moment, which you won't see. But I can toggle the rejected. So these are the data. This is the data that was rejected by QINSy, retained in the QPDs, because we didn't do the QPD reduced. We did the QPD which had all the rejected data in, and so we can, for a rec, you can go back in here, select the area around the rec that you want, and then unreject it. So that's now we've got all the rec data in, and then we can turn off the rejected. Just drag that vertical exaggeration down, and then color by that. So this is all the information we have, and if we select, say, the shoulder sounding here, select by shoal. Then if you look at down here on the bottom, then you'll see that you've got the horizontal and vertical error for that sounding. So that's showing you where and you can look at that to make sure your numbers are about right on it. This is ping, which is record, and sub-record is beam. So this is beam 334, so this is out on the outers a little bit. And then, of course, Fledermaus has the best cube implementation. And you can either see what's been going on. I can select that shoal sounding, and then I can make the cube surface be exactly at that point. So I'll get back to mine. So whereas a big cube, that's where the cube's selected. Where there's a little cube, that means there's a solution there, but it's not necessarily the one that you want. And if you really want to see what you've been doing on that one, You can also make this a feature flag. Oops, let's choose the right one. Feature. Or hit the F key. Excuse me. And then when we export this, one of the PFM nice features you have is this show flags. And I'm going to zoom in so you can see it and turn that off. But you can see on the top of that rec there, you got this little white flag that's sticking up. And on a big data set, it's a bit easier to see, and you can see where you've been and where you've done it. Now, the thing with with the Magic and QPDs is you read the QPDs in, but you can take them back as well. So if you finish cleaning this data set, for instance, I haven't done anything with this yet. This is still got all the spikes in, but I can say take this area here, use the cube surface to filter the soundings. Just put value in there for a moment, just on this selection. And this is now, so it's just automatically got rid of the spikes. One of the things we're going to be doing is bringing the spline filter from cloud into this cube filter here, which will make it even tighter and a much better job. That's not there yet. But if we did that for the whole area, then once we're finished here in Fledermaus, every time you do anything in the PFM, it saves the PFM. And let me go back to my DMagic project. Not that one, but that one. Yeah. So if we're finished processing these files, we just select the files that we want, and then on the PFM over, well, actually we don't even need to do that. On the PFM over here, you have the option to unload the PFM. If I turn it on, you get the option to unload the PFM. And this will take all the edits we did in the PFM, and it will take them back to those QPDs. So your QPDs will then be nice, clean QPDs. Still flagged, so you can go back in and change them again. But that way you can then carry on and do any, if you do use some of the plotting functionality or dredge volume calculations, all that sort of stuff that's in Processing Manager, you can do from here. So that's the QPDs into Fledermaus. I'm just going to cover something here on the, and this is a very, very specific thing for the Raison 7000 series, specifically 7125s, and specifically for if it was logged with QINSy prior to 2011. Prior to 2011, the 7000 record, which is where all the power and gain settings is, wasn't stored in the DB file. So when you come to, if you have historical data, then you're going to have to override the settings that are in there. So luckily with the 7125, you run it pretty much flat out anyway, so you don't tend to change too much in it. But these are the settings that I use for this particular project. This is in the processing parameters in the Sonar default section. You select custom override all. You select, this is part of FMGT for the backscatter that you don't normally have to go to, but this is particularly for this one. You choose what sonar it is, and then you set these features, these values here. And the easiest way of setting those values is to look up the autopilot settings, look at the, basically pick the average range value that you're going to have for your data. In this case, I picked the 75-meter range, and then I just put these values here into these spreading transmit power receive gain here. And in this way, you actually can get a decent backscatter mosaic and ARA values out of it. So this is only for pre-2011 QINSy versions. So I'm not quite sure what the actual release QINSy was, but this is just to make sure that if you have older data, then this will be an issue. Just to show you a couple of things. This is sort of, actually I can just do it from here actually. The near future, and I'm not No one's told me the date. I'm not holding back on you. No one's actually told me when when this will happen, but it's not that far off. The DB files which contain the backscatter, they're going to be used in FMGT for doing the backscatter processing, and the Bathy data will go from the QPDs. So you get nice clean data in the QPD, it's all tidily adjusted, sound velocity corrected, and then you just extract the backscatter from the DB. So there's no more messing about with XCF, GSFs and all the problems that remained in there. This also makes it a lot easier for us to develop the software. With new sonars get added, we don't have to wait for another file format to be created and the right settings to be created. We just need to do it internally, and it will be so much better, so much quicker. And again, you can do this on the fly. You can use FMGT on the fly already if you're really only using a Kongsberg system. But this will mean that we'll be able to use FMGT online, creating the mosaic as soon as the DB file and the QPD file have been created. We'll be able to load those in and create the mosaic on the go. So that will save an awful lot of time in post-processing. Later on, we'll be extracting the water column data from the DB file, or maybe even creating the GWC file, which is what the FM Midwater uses. We might actually create that online in QINSy. Again, it's all to save mucking about with different file formats and things. And the real goal here is to hit that start logging button in QINSy, and then the last time you really actually touch a file is when you don't read, and then you just go straight to say an Esri geodatabase. You could do that without actually changing file formats or changing anything to do with the data that's been recorded. And also the nearest future is also launching Fledermaus from within Processing Manager. Now this, I've got you can see on this one here, this is a little button here that will show that will launch Fledermaus. That will actually at the moment create a 1 meter PFM and launch it. This isn't actually in a release at the moment. And again, in the sounding grid editor, you can also launch Fledermaus from within that over here too. So that'll be quite nice. The future further functionality is really moving, morphing, if you like, DMagic into Processing Manager. So rather than from having to, you'll have everything within Processing Manager. You go select the area that you want to make the PFM from, to create the grid. There'll be, so all of that DMagic functionality will be there in Processing Manager. And again, common DTM surfaces across all the applications, so that the same surface, same file is open up in everything. And then of course what everybody wants is multiple cell sizes, real-time processing and all the rest of it. This will go with the common surfaces because there will be multiple cell size. So that's the bit further off. The initial the FMGT with the DB file and the QPD file, that's going to be the first one of the really integrated stuff carrying on there. So that's pretty much me done. I'll hold for questions. Erin handles all evaluations and America support. Kat here in the UK office, she handles all the Fledermaus support and things over here. Well, not support, but the guidance and things. So if you want to be guided through how to bring the data in, what I've explained today, if you want to have a one-to-one over a GoToMeeting or request a client visit, then depending on where you are in the world, then those are the two people to get in touch with. And when things go wrong, because they do, then support is where you send stuff to. So that's me. So thank you very much for listening, and question time.
Hey Duncan, thanks for that. That was great. Can we, before we get into questions, can you just kind of finish up with a few minutes on just transferring the results to ArcGIS? Because we had that in our overview, and I just wanted to make sure to touch on it.
Oh, okay. Yep. No, I can do that. Remember, this is a 64-bit machine that I'm on. The ARC interface is only 32-bit. That's an Esri limitation. That's not a Fledermaus limitation. But it's, as I showed you at the very beginning, you can have both 64-bit and 32-bit Fledermaus running on the same computer. So if I do, I need to be in the Fledermaus 32-bit world. So if I bring up that that PFM, and that was in this one. So that's our PFM. Choose my cube surface. Extract the entire area. And then we can create. If you don't have an ARC license running, and you don't have the 32-bit option, and you don't have ARC installed, you won't actually see this button here. So we want to add an ARC workspace, and this either allows us to create our own geodatabase or link to an existing geodatabase. I'm just going to create a geodatabase. So let me stick it. Esri. So that's now created it. There's our little link. PFM is the one that you can actually do most with ARC. But I'm also going to do with a PFM. I want to make some contours, so I'm going to I have to create a separate, just a normal digital terrain model. So this is our normal digital terrain model. I can select that, and I'm going to just do some contours. Quick set of Bathy contours. So there's our contours off our cube surface, very quick and easy. Our contours here. Again, if you don't see the ArcGIS, you don't have all the necessary components running. I'm just going to transfer them as contours. So contours into that. So you can have up to 10 different ARC databases if you want. Both version 9 and version 10. So that's the those in there. And then there's our contours within our database. On the surface, we can also transfer the image. So we can do geotiff if you want to. And we can do the same thing with rasters. So both the X, Y, Z part of the surface can go into ARC. The X, Y, and say backscatter part can go into ARC as well. And then within the PFM, we have the option here to sort of run plotted sounding filters over the data. So I can run it's got quite a big chart scale. 50,000 will do. I hope this isn't going to take too long. This is selecting the soundings, the shoal sounding within a particular minimum distance, in this case 250 meters, which might be a little bit too small. But I don't know, there we are. And then if I want to see which ones they are, they've got plotted. We have our plotted sounding features here, so we should be able to. It's quite hard to see, but you got some of the stuff in here, there. And with these ones, we have various options. I'm just trying to find where my where it's gone. It's normally for some reason my ARC button's not coming. Okay. But you can select basically all these different functions here. You can do with the plotted soundings, this is transfer the survey area. This is the actual bounds of the survey area that you can bring into. So that's sort of from straight into the geodatabase here. And again, if we want to, we can bring these out. So I can, if I remove our contours here, I can actually go into my database and load my contours into the scene. They're going to come in as contours, specify a coordinate system, and there they are within the art workspace, but on Fledermaus. So it's a two-way thing. It's not just going into a database. You can bring stuff out, so then you can do surface difference calculations and things like that. So
Thanks,
that's all.
Duncan. That was a good summary. Thank you. What else do we have here? So in the beginning, you showed that you added in the Fledermaus modules and stuff into QINSy, but that's not a necessary part of the workflow, right? Do you understand my question? Oh, Duncan.
Say that again, sorry?
Yeah, sorry. No, in the beginning you added in the Fledermaus modules into the QINSy interface. That's not a necessary part of the workflow, right? You could just... No,
it's not necessary at all. It's just sort of if you are using both, then it's all in one place. So.
And we had a question.
Yeah, not necessary.
Can you touch on what happens if you do some editing in cloud? Is there any loss back and forth? How does that work out?
If you're doing stuff in cloud, then you want to do that first, I would say. And the difference with editing in cloud and editing in Fledermaus and in the PFM is that if you have a small data set or maybe a long, thin one, like along a pipeline, then that's probably best to be doing in cloud at the moment. But if you have a big data set, area-wise, then that's best to be doing in Fledermaus. It's just the way that it handles the sizes. The cloud creates these QTM files that it uses, and then you have to send them back into the QPD. So I would, if you are using cloud, I would use cloud first and then use Fledermaus. But I don't think there's any need to do it one way or the other. Providing you haven't got both open at the same time, you want to do one then the other, whichever way you do it.
All right, thanks. We have a question that just came in, so I haven't answered it at all. I'm going to read it out loud. Is there any difference between creating GSF files from Processing Manager using the export function compared to creating them from Replay Manager using the export function, assuming the QPDs have been created with no online flags?
I would say no, but I would say there shouldn't be any difference, but Hans might be... because basically it was done in Processing Manager because that's where you've done the QPDs already. This is just because it's next to the XDF as well. So.
Hans, did you have anything to add to that? Should we trust Duncan?
No, I don't have. I think I would give it the same answer as Duncan did already.
Okay. And then we just had a question come in. Is pipeline processing functionality to be included and where?
That's a very good question. And that's sort of it's on the road at the moment. It's in Validator and QINSy, and if you want to do long profiles and cross profiles off a DTM, that's in Route Planner or Route Planner, depending on which side of the pond you're on, in Fledermaus, and ideally we would make them all in one place, and ideally there's a definite need industry-wide to improve pipeline data processing, and we hope with the two packages and the knowledge that we have with both systems that we'll be able to really, I mean, that's one area that's really a key area.
All right, thanks, Duncan. And the last question, and then we'll just sum up and we'll close up because we're after 11. But can you just summarize, because there was a question about the whole backscatter thing. Can you just summarize where we are now with the XTF, GSF, and where we're going in the future one more time?
Yeah, with XTF, GSF, that covers Reson 8000 series, Reson 7000 series, and also the R2 Sonic system. Not TruePix yet, but TruePix is a different processing flow line to normal snippets. So I think if you want to use object detection size scan, you use TruePics. If you want to actually work out what the seabed's made up of, then you're better off using the snippet part from R2Sonic. Those two are basically in the XTF GSF export. The short-term goal in probably the next few months is to have Fledermaus or FMGT reading the backscatter out of the DB file. That doesn't matter what sonar it is, Kongsberg, Reson, R2Sonic, maybe even GSWatt. It will allow us to make things a lot quicker and a lot faster, and it'll be a lot better for the user too. So shortish future.
All right, great. I think that's it. We had a few other questions, mostly about formats and stuff that we answered to all of you. So if you look in your dialog box, you should see some public answers about R2Sonic and TruePics and also their water column format. I did record the webinar, so if you are a client and you would like the recording to get to your colleagues or to review some things, we are still using the same download site that we've been using for a couple of years now. But if you don't have that information, just shoot me an email and I'll get it to you. Thank you all again for coming to our webinar, and thank you, Duncan, and my panelists for hanging out. And we will see you all again hopefully soon on the next webinar. Thank you. Bye-bye.